You're probably wondering what this is. Maybe some of you are good enough to know what it is already. But if we flip it over, it's a dynamic transistor checker. And I recently picked this up at a thrift store for pretty cheap. It was pretty dirty and I was cleaning it up. While cleaning it up, I took it apart to test each and every one of the pieces in the circuitry to confirm it was working. And then I realized I also have this book. Now, this book is probably very useful for people because it tells you about what basic electronics are, and it tells you what each function of the electronics are. And that's what we're going to talk about today. Let's talk about this guy right here, the resistor. And what is a resistor? What's its functionality? What's a color code? How do you read the color code? How do you test a resistor with a multimeter? And finally, we'll talk about, is there a way to determine whether the resistor is good or bad based on the color code versus the multimeter reading? All right, so let's just jump into this book here, and we're going to start talking about what are resistors. And here it says resistors resist the flow of electricity. This makes them very useful for reducing current to light emitting diodes, or LEDs, which can be damaged by too much current. Resistors are also used to divide a voltage into a smaller voltage. I think it's known as a voltage divider as well. Resistors are used to increase the time required to charge capacitors and also speed up the discharge of capacitors. They're also used to control the gain of amplifiers. And this is what a resistor looks like. As you can see, there's a couple of different bands here. We're going to talk about those bands soon, but they're color codes, and they help determine the value of a resistor. But you could also see this thing here. And what is it? This thing is this is a resistor on a schematic. I'll show you what that looks like in a minute. But let's talk about a LED for a minute, a light-emitting diode and resistors and how they play a factor. In very short, if I hook up a 9-volt battery, depending on the resistor, if I hook up a 9-volt battery to the resistor, maybe this LED will be fried out automatically. It's too much current going to the LED than it can handle, and it just doesn't work anymore. Or maybe it works once or twice. After a couple of times, it either gets dimmer or just stops working. Well, that's because the amount, the source of your current or your electricity was 9 volts, and maybe this couldn't handle 9 volts. So in line here, and there's some math for it, we could talk about it another day, but in line here, you might place, your electrical source, being a battery, for example, a resistor, and then the light-emitting diode here, as to reduce the flow of electricity to this thing, prolong its overall lifespan, essentially. And so that kind of gives us an idea of what a resistor does or its functionality is. And let's just take a look at the schematics, just so you could see what a resistor looks like in a schematic chart. So I don't know, this is a circuit for something or a diagram for something. But basically at this point you have a ground, and you don't need to know all that right now, but basically you just need to know that when you see these little, what looks like 3 M's or 3 spikes, these are resistors. And I wanted to show you these in a actual schematic, because now we can talk about the polarity of a resistor. And some of you already know, if you see a resistor on a chart, some things in life are sensitive to the polarity. So like a diode, if you poke the diode up the wrong way, it's not going to function correctly. But if you put a resistor either this way or you put it this way, it doesn't matter. The resistor is going to work fundamentally correctly the same way in general. So, you don't have to worry about, the resistor should go this way or that way. The resistor is going to be, it's going to be universal regardless which way you put it. But there is something we need to know about resistors, and that's the color codes. And as you can see here on this resistor, and as you can see here on this resistor, it's hard to tell, but if you look really closely, you could see that the colors start closer to one side than the other. In this case, it's being the yellow, and it goes down. You see there's a little bit more distance in between what is gold, the end of the resistor and the gold. And so that's where we're going to actually start to read our resistor values, is at the yellow, because it's closest to an end. And then we read the resistors left to right for color codes. And the color codes help determine what the value is of the actual resistor. And to do that, let's go ahead and pull out a notepad and a pen, and this guy again. So this is the one we've been looking at. And as I mentioned, it's yellow. I'm going to write that down, yellow. And we read it left to right from that spot. So yellow and then violet. And my handwriting is going to be really sloppy because I'm actually looking at this more. And then green. And then the last one, it's hard to tell on camera, but that's actually gold. And gold's a multiplier. We're going to talk about that in a second. So we have yellow, violet, green, and gold. And it's just going to be labeled band 1, band 2, band 3, and band 4. Okay, I rewrote this, and now we could actually just talk about what this all means. We've read left to right, meaning here's our resistor, and our color was closest on the left-hand side. That makes it start with yellow, and we read to right. Now we're going to read right to left, and what we're doing is we're reading band 4, then band 3, band 2, and band 1. And let's talk about band 4 first. And typically the last band you're going to see on a resistor, and that's called the tolerance. Okay, so gold equals the tolerance. And interestingly enough, this book kind of states the fourth band is the tolerance, and it tells us our tolerance levels is plus or minus 5%. I'm going to do that again. Okay, plus or minus 5%. Now, basically, that's tolerance is the amount of error that the resistor may have or can resist. And in this case, there's a 5% resistance allowed or error level allowed in the resistor. So then we go up one, we're going to go to green. Now, the second to last band is always what they call the multiplier. And if we look here, actually, on this chart, here it is, it says 3, and we can see it's pointing to a multiplication. So the multiplier. And, you know, if that third color or the second from the right was brown, we would multiply our value by 10. But in our case, it's green, so we find green, and it's times 100,000. So times, or, you know, we're just going to write here multiplier. And the value is now multiplied by 100,000. Interesting, right? But now all we got to do is we're going to go read band 2 and band 1. Band 2, again, that's violet. We're going to go find violet, and it's a value of 7. And then our yellow is a value of 4. Yellow 4. So let's just make this really easy now. We had the 4, and we had a 7, okay? And we had the multiplier of 100,000. And quite simply, we're just going to take the 4 and the 7, and we're going to add 1, 2, 3, 4, 5 zeros to it. 1, 2, 3, 4, 5 zeros to it. And here we have 4.7 mega ohms, or millions. And we have our plus or minus 5%. Hey, but there's an easy way to do things, and I think that simplicity is always good. I wanted to show you the real way, just in case you don't have access to the internet or something. But yeah, here is a site, Digikey. I'll link it below, and you can select the number of bands you have. And again, we're working with a 4-band here, and our first color is going to be yellow. And so, again, yellow. And then our second color was violet. Our third color, the multiplier, was green, and our tolerance level was gold. So once we select all those, and we hit search catalog, what happens is it pops up and it gives us a list of the resistors we could purchase from Digikey, but it also tells us straight up our resistor value being 4.7 mega ohms at 5% tolerance. So that's what we know, but now we should probably test it with a multimeter to confirm it is 4.7 mega ohms. So let's do that. And actually, there's a lot of different kinds of multimeters, so I'm not going to go into how to use a multimeter per se, but this is one of the multimeters. It's a more analog multimeter, and in short, plug in your red prong into the right side, plug in your black prong into the COM side, take this dial from off, and typically switch it to 20K to get an idea of where you're at. And you can adjust there for resistance, of course. But let me show you the meter that I'm using and kind of just show you what I have to do here. And thank you, Smoking Ape, for this meter. My meter fried out. I had a meter like the one you just saw, and it didn't do too well at the fault of my own. But here I have this circuit again. And remember, this is the resistor over here that we're going to test the value on. Now, I want to mention again, polarity of a resistor doesn't matter. So it could either go this way or it could go this way. And it's the same thing with the prongs. I could either hit them this way or I could hit them this way. And let me show you the multimeter at the same time here. So again, it's set to auto, which is really cool because it'll automatically figure out what I'm looking for. And I'm just placing a prong on either side of the resistor. And it's doing its job, and it says 4.700. That's a near perfect resistor. You know, 4.697 is definitely within 5%. So that's good. But what I want to show you here is if I do this backwards, it'll still give me the same result. Now, we're seeing some weird values there for just a second, but I think that was me fluctuating on a different contact. So there we are, 4.699. definitely within 5%. Now, how do we know a resistor would be maybe not functional correctly? If this is supposed to be a 4.7K ohm and we saw something like 1.2K ohms, you're outside of that 5% level. So anything within a 5% level should be considered okay for the resistor. And so what is it that you need to determine what 5% of 4.7 is? Well, let me pull up a calculator here. And the best way you could do it is take 100% and subtract 5%, which is 95%. So 0.95 is how you would write 95% on a decimal, and multiply it by 0.47. And as long as our value is greater than 4.465 mega ohms in this situation, our resistor is considered good according to the logic there. So I just wanted you to be aware of that. Let's wrap this up here and talk a little bit about everything that we learned. All right, so I had a lot of fun doing this. We talked about resistors, we talked about color codes, and we talked about multimeters and kind of why you would want to use a resistor in certain scenarios. The book was very handy to help us out. Perhaps you didn't understand any of that, and that's okay. I'm going to give a very basic example, which may or may not make sense, but it kind of made it click a little bit for me, and hopefully it'll do the same for you to at least understand. If none of that made sense, just picture like a thing of grease or some kind of toothpaste bottle. And really, there's a hole in here that delineates how much or how little paste can come out or grease can come out. And as you squeeze, you might get a little bit more to come out. But there's a theoretical maximum limit of something that can come out here. And if you break that limit, maybe it stops working, or you blow out your bottle here. In other cases, maybe you blow out your resistor. But in any case, the amount of grease that was going to flow out of here is lineated by a small little hole. And I guess they were kind of comparing that to a resistor in a way. I hope you found some kind of value in this video. Thanks for watching. Please consider subscribing if you did find value in this, and you might like the video that I'm posting right here. But until next time, I'm Ham Radio Dude. Goodbye.